Have you ever wondered about the invisible forces that power our world? Electricity is a fundamental part of our lives, yet it remains a mystery to many. Today, we'll unravel some of that mystery by exploring the basics of electronics, specifically focusing on voltage and current. In the realm of electronics, voltage is a key player. It's the energy required to move a unit of positive charge from a point with a lower potential to one with a higher potential. Think of it as the force that pushes electric charge around a circuit. This force is also known as potential difference or electromotive force, EMF. Voltage, measured in units like volts, kilovolts and millivolts, is essentially the driving force of electricity. On the other hand, current is the rate at which electric charge flows past a point in a circuit. Imagine a river. The current would be the amount of water passing a given point in a certain amount of time. In electronics, it's measured in units such as ampere, milliamperes and microamperes. So if we keep the river analogy, the stronger the current, the more water is moving past that point. It's crucial to remember that current always flows through objects, while voltage is applied to objects. And to measure these in a circuit, an oscilloscope comes in handy, allowing us to see voltages or current as a function of time. Now, let's touch on some important rules about these two. First, Kirchhoff's current law states that the sum of currents entering a point in a circuit equals the sum of currents exiting it. This is due to the conservation of charge. In simpler terms, what goes in must come out. Secondly, Kirchhoff's voltage law states that the sum of voltage drops around any closed circuit is zero. This means that the total voltage supplied to a circuit loop is equal to the total voltage drop across the devices in the loop. Lastly, we have power, which is the multiplication of voltage and current. It's measured in units like watts, which equates to 1 joule per second. Power can be transformed into heat, mechanical work, radiated or stored energy. In conclusion, voltage and current are the fundamental building blocks of electricity. Voltage is the force that pushes the electric charge, while current is the rate at which this charge flows. Remember the laws of Kirchhoff and the concept of power to better understand and navigate the world of electronics. With this knowledge, the mysteries of electricity become a little less mysterious.